Hello and welcome to the third lesson of Math 2, Unit 1. Today we're going to be talking about how to identify functions from tables. Now most of this should be a review from secondary Math 1, and then we'll add one more little component. Let's get started. So during this lesson, you should learn how to identify linear equations based on table. That's a Math 1 concept. Identify exponential equations based on a table. Once again, that's something you should have done in Math 1. And identify quadratic equations based on a table. That's the new one that we're going to do today. All right, some quick vocabulary. The input value is the x value of the equation. Generally, it's the x value. The input value is the thing that you control. You're going to select what you put in, and then the output, which is generally the y value, is the thing that comes out. You don't have control of the output. You have control of the input value. A common difference is the number that you add or subtract to each output in a linear equation. So a common difference is the number that you add or subtract to each output in a linear equation. The common ratio is the number that you multiply to each output in an exponential equation. The first difference is the difference between consecutive outputs. Difference between consecutive. Consecutive means one right after another. The second difference is the difference between consecutive first differences. Okay, so if you want to pause the video, take a look at the slide, write those down, it'd be perfect. Okay, quick review. Equations always have equal signs. So if I write something like this, 2x plus 3 equals 7, that is an equation. Okay, we know it is an equation because of that equal sign. If I write something like this, 7x minus 4, we call this an expression. Forgot it there for a minute. Expression. Linear equations are a type of equations that create a straight line. The parent function is y equals x. Now remember, a parent function is the most basic function of a most basic form of a function. And exponential equations have the variable, usually x, in the exponent. The parent function is y equals b to the x. So I look at my variable here, x. It is in the exponent. That's how we know. All right, so identifying linear relationships from tables. So these are kind of my checkoff points. The input value, usually x, increases by the same unit. So we have to check that off. While the output, the y value, is increasing or decreasing or adding and subtracting by the same number. That's called the first difference. We have to check that off. And the number that the output value is increasing or decreasing by is called the common difference. So common difference and first difference are kind of the same. So that's what we have to do to determine if something is linear. So let's look at this. Is my input value, so my input is my x values, is it increasing by the same amount? Each time I'm adding 1. We're good. So that checks off. Do I have a common ratio? So a common ratio is something that I multiply to get from one thing to the next. Nope, doesn't look like it. That's not it. Do I have a first difference? 14 to 7. I am adding 3. 17 to 20, adding 3. 20 to 23, I am adding 3. 23 to 26, I'm adding 3. 26 to 29, I'm adding 3. So I have a first difference. Check. We know this is linear. Okay, now let's do this one. Same thing. My input value. Am I adding the same number? 1 to 2, 2 to 3, 3 to 4. Yep, I'm adding 1 each time. Check. Do I have a common ratio? Am I multiplying? Well, I have a shot here. Well, 3 times what is 3, or is 9? That's 3, so 3 times 3. 9 times 3 is 27. 27 times 3, 81, and so forth. So yeah, I have a common ratio. Check. So that means this is exponential. Okay, so if I end up having a common ratio, that gives me an exponential function. Now let's learn about how to identify a quadratic relationship from a table. Same basic steps are going to apply. I'm going to check for my input value. Yep, I'm adding 1 each time. We're solid. The next thing is I'm always going to check for a linear relationship and an exponential, and then I'll check for my quadratic. Okay, so 5 to 7, 7 to 13, well, it's not linear, I can see that. Exponential, probably not. So we need to find something called the second difference. So the first difference we know is saying, well, I'm adding 2 here, well, and then I'm adding 5. Oh, nope, adding 6, sorry. 13 to 23, I'm adding 10. 23 to 37, I'm adding 14. 37 to 55, I'm adding 18. Okay, and then we look at our second difference. 2 to 6, I'm adding 4. 6 to 10, I'm adding 4. 10 to 14, I'm adding 4. 14 to 18, I'm adding 4. Right there is what's called my second difference. If my second difference is the same on all of these, we know it's quadratic. Alright, is this the one that we just did? Yep, so we just did that one. So we know that that's quadratic. Alright, now here's a now you try problem. I want you to pause the video, try it out, and then resume it, and we'll show you how to go through this. Okay, so like always, I'm going to check to see if I have my input value are all going up by the same. We're good there. Do I have a common ratio? Doesn't look like a common ratio. Now we'll try a common difference. I'm adding 1, adding 3, adding 5, adding 7, adding 9. Nope. So that's my first difference. So don't have that. Don't have that. Second difference. Plus 2, plus 2. It's looking good. My second difference is all the same. So we know that this is quadratic. Okay, let's try this one. So once again, pause the video. My input values all look good. Common ratio. 2 times 2 is 4. 4 times 2, nope. So I don't have a common ratio. Let's try a first difference though. This one looks pretty good. Plus 2, plus 2. Boom. We have a first difference. So we know this is linear. Okay, let's try this next one. Input values. Are they all the same? They are. Do I have a common ratio? 2 times 4, or I mean 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Common ratio. So I know this one is exponential. Alright, so there you have it. If you have any questions about how we did anything in this video, please come and talk to me and I'd be glad to help. Thanks.